Welcome to this presentation. Today we are starting on question 21. Question 21 is saying ethyl glycol, which is having this formula, is a common automobile antifreeze. It is used as anti-freezing agent. Calculate the freezing point. They are asking to calculate the freezing point and the boiling point of solution containing this mass 651 gram of ethyl glycol and this mass of water. The molar mass of ethyl glycol is 62.01 gram per mole, and the Kf was given, and the Kb also was given, the boiling point constant and the freezing point constant. They are asking to calculate the freezing point and the boiling point of the solution after adding the ethyl glycol in the solution. What is the freezing point and boiling point? As we know, when you add the solid to a pure solvent, either you will have the boiling point elevation and the freezing point depression. The boiling point is going to increase and the boiling point is going to decrease. Now they're asking the new freezing point and the new boiling point. Let's quickly jump to the answer. We need to use the formula to calculate the change in temperature which will occur when the solid is added to the pure solvent. And here we have dTF, which is the change in temperature for the freezing point, so which is equal to Van 't Hoff constant or Van 't Hoff factor times this constant, the freezing point constant, times the molarity. And this molarity is equal to mole of solid per kilogram of solvent. Again, also the dTB, the change in temperature for boiling point, it is equal to the constant, the Van 't Hoff constant, times the boiling point constant times the molarity, which is the mole of solid per a kilogram of solvent. Now that is what we need to calculate, because we are having an organic molecule. That means the I will be equal to 1. It will not dissociate. So I will not be, I is equal to 1. So if we are having a molecule like a sodium hydroxide, like a sodium chloride, in this case we dissociate to give 2 ions or 3 ions. Then here the I is equal to the number of ions after dissociation. But this one, the I will be equal to 1. Now let's see this. We don't have this M, which is the molarity. To find the molarity, we need to find the mole of solid per kilogram of solvent. So here we have the solid, the mass of the solid, we have it. You can determine the moles by taking the mass over the molar mass. Here also we have the mass of the solvent, but we need to change it in kilogram. Here we determine the mole of solid by taking the mass over the molar mass, the mass of solid over the molar mass of solid. So the molar mass of solid is 62.01 gram per mole, which is the molar mass of ethyl glycol. We get the mole of solid as 10.5 mole. After getting the mole, then we determine the molarity, which is equal to the mole of solid dividing with a kilogram of solvent. Then we get 4.19 mole per kilogram, or 4.19 molar. After getting molar, we have Kb, and we have the Van 't Hoff constant, which is 1. Then we can replace the value and get the change in temperature for the freezing point. We can also determine the change in temperature for boiling point. Now we can calculate the freezing point, because the normal freezing point for water is 0. Then because we have added the solid, we have freezing point depression. In this case, it will be 0 minus the change in temperature. Then we have negative 7.79 degrees Celsius as the new freezing point of the water. We also determine the delta B, which is the change in temperature for boiling point. So we are replacing the values. Then we get 2.18 degrees Celsius. And remember, we have the boiling point elevation. The boiling point of water is 100. Then for the elevation, we need to add 2.18. That means here the solution will boil at 102.18 degrees Celsius. You can see that adding a solid, we have a freezing point depression, decreasing the freezing point, and you have also the boiling point increase. You have the boiling point elevation when you add the solid to pure solvent. That was question 21. Let's see question 22. Question 22 is saying a 7.25 gram of sample of compound with empirical formula. The empirical formula of compound was given as C5H4 is dissolved in 301 gram of benzene. That means that we have the mass of the solvent benzene. The freezing point of the solution is 1.05 below that of pure benzene. That means here that is the change in temperature that was given. The change in temperature for freezing point was given as 1.05 because they are saying the freezing point of solution is below 1.05 is 1.05 below the pure benzene. That means you have the normal freezing point of pure benzene, which is which has a particular value. Then it has decreased by 1.05. That means the change in temperature is 1.05 in this question. What are the molar mass and the molecular formula of this compound? Now they want to know the molar mass and the molecular formula for this compound. Remember, you covered the empirical formula. If you have the empirical formula and you have the molar mass of the compound, you can determine the molecular formula. Here, that means for us to determine the molecular formula, we should have the N, or the number of mole. Should have the number of mole for this one. Here we have the empirical formula, and to determine the molecular formula, we should have the N, which is the number of mole. That's what we are looking for. Then they are saying what are the molar mass. So we need also to determine the molar mass. The molar mass and the number of mole, that's what we want, so that you can determine this molecular formula for the compound. The Kf was given, and for us to determine, to obtain the number of mole, and also to obtain the molar mass, so we should use the molarity. The molarity was given, it was not given. Let's see, let's quickly jump to the answer. So we have the mass of the compound 7.85. We have the mass of solvent, which is 0.301 kilogram. Then we have here delta TF was given as 1.05. The KF was given. The I we don't have and the M we don't have, but we know that it is the benzene. Here we have the pure benzene, and the solid we know it is C5H4. So this is also inorganic. That means I will be equal to 1. So we can use this formula delta TF IKF times M, which is the molarity. And here we don't have the I times M, which is the molarity. The KF we have, and this one we have. Then we can determine the I times M. Can you find the I times M, or you can find the molarity, because we know I will be equal to 1 because it is the organic solvent, organic molecule. Then in this case we have the molarity, which is equal to mole per kilogram. So we have taken the delta TF 1.05 dividing with the KF. So that times the 1. Because we know this is 1, then you get this molarity. After getting the molarity, then you can determine the number of mole. Molarity is equal to 0.205 mole per kilogram. Let's proceed. After getting the molarity, we know what is the molarity. Molarity is the number of mole of compound dividing with kilogram of solvent. Then what do we have? We have this one, the molarity. We have a kilogram of the solvent, then you can determine the number of mole. That means the number of mole will be equal to the molarity times kilogram of solvent. So we can replace the values. The number of mole will be equal to 0.205 times 0.301. Then you get this number of mole. After getting the number of mole, you can find the molar mass. We know the number of mole is equal to mass over the molar mass. That means the molar mass will be equal to mass over the moles. And the mass we have it. Then we can replace the values. Then we have the mass of the solid, 7.85 dividing with the moles. Then we get the molar mass. Then by having the molar mass, and we have also the empirical formula, you can determine the N. Then in this case, we have this empirical formula times the N, which is equal to this one. Then we find the N. Then we find that the N will be equal to 2. Then after getting N, we can find the molecular formula. That molecular formula will be equal to, here we replace 2 here, we press 2. Then times 2 it will be C10, times 2 it will be H8. This is the molecular formula that was asked in this question. Question 23 is saying the freezing point of water is 1 degree Celsius. Calculate the freezing point depression and the freezing point of an aqua solution made by dissolving 50 grams of ethylene glycol in 50 grams of water. The KF was given. So here they are asking the freezing point depression, which is the delta T, F, and the freezing point. So what do we have? We can use the formula. We know the kilogram of the solvent, because the molarity is moles per kilogram of the solvent. You convert the mass of the solvent into a kilogram. So that means 50 grams of water we are converting to kilogram. We can find also the moles of solid. The moles of solid, we have the mass of the solid, which is 50 grams of glycol, of ethylene glycol. You can divide it with the molar mass. The molar mass of ethylene glycol is 62. You get these moles. After getting the moles, then you determine the molarity. The molarity is equal to the moles over kilogram of the solvent. Then you determine the freezing point depression is delta TF by using the formula I KF times M. The KF was given as 1.86. Then we have also the molarity that you have determined. Then you have the freezing point depression. After getting the freezing point depression, you take 0 minus this one, so that you get the freezing point of the water, the new freezing point of the water. That was question 23. Let's quickly move to question 24. Question 24 is saying calculate the concentration of urea that has an osmotic pressure of 30 atmosphere at 25 degrees Celsius. Here we will use the formula for the urea. So what is the formula for the urea? We have it. We need to use the formula for osmotic pressure. What is the formula for osmotic pressure? So here we know that the osmotic pressure is equal to I, the Van 't Hoff constant, times the M, the molarity, times the air gas constant, times temperature. Then the M will be equal to the osmotic pressure, dividing with A times the R times T. Here we place the value 30 atmosphere, which it was given as the osmotic pressure. Then the others replace the values. This is the gas constant, this is the temperature. The temperature should be in Kelvin. That's we have 25 degrees Celsius. So if you convert to Kelvin, we add 273. In this case, we have 298 K. Then after replacing the value, you get 1.23 molar. That was one of the very easy question for question 24. Let's go to question 25. Question 25 is saying what is the osmotic pressure of 0.55 sodium chloride at 25 degrees Celsius in units of atmosphere. Here we have the molarity of sodium chloride. Here the Van 't Hoff constant will be 2 because we have sodium chloride. That's what you need to know. Let's go quickly to the answer. We know that the osmotic pressure is equal to this one. That's what they're asking. What's the osmotic pressure? Of course, here we know that the I is equal to 2. Here also the molarity we have it. The gas constant we have it, and the temperature, but they want it in units of atmosphere. That means you have the M, we have the I, which will be equal to 2 because you have sodium chloride is an electrolyte. You have the temperature and you have the gas constant. So you can replace the value and find the 26.9 atmosphere. Here we use the gas constant, which is in atmosphere. Then here we get the atmosphere. That was the question 25. Let's see question 26. Question 26 is saying the vapor pressure of pure water. The pure water the molar mass was given at 50 degrees Celsius is this millimeter mercury. The vapor pressure of pure water. A solution containing 1 kilogram of pure water, so that means the mass of the solvent was given, and the non-electrolyte cyclose. Cyclose is a non-electrolyte, that means the Van 't Hoff constant will be 1. Has a vapor pressure of this millimeter mercury, 90.8 millimeter mercury. That means the vapor pressure of the solution. So we have the vapor pressure of the solution and the vapor pressure of the pure solvent. What's the boiling point elevation of this solution? Given that the abilistic constant or the boiling point constant was given as this one. If the solution has a density of 1.08 gram per milliliter, what is the osmotic pressure of this solution at 50 degrees Celsius? They asked me to use the gas constant, which is equal to this one. So what's the boiling point elevation? We need to get the delta TF, or the change in the delta TB, the change in temperature for boiling point. But we don't have the molarity, so we can see how to calculate the molarity from the vapor pressure of pure water and the vapor pressure of the solvent. The same as then for the osmotic pressure, that is, as they are asking us to calculate the osmotic pressure, we don't have the molarity. So we will see how to calculate it by taking the number of mole, looking at the number of mole, by see whether we can use the number, we can find the number of mole, and then after finding the number of mole, we divide it with the volume of the solution, then we get the molarity. Let's quickly see how we can use the vapor pressure that was given, the vapor pressure of the solution and the vapor pressure of the pure solvent to calculate the molarity, then so that we can calculate the delta TF for the boiling point elevation. So here what do we have? We have the molar mass of the pure solvent, we have the P naught, which is the vapor pressure of the pure solvent, and we have the molar mass of the solid, and we have also the vapor pressure of the solution. If molar mass of the solid, we have it, then you have also the mass of the solid solution containing 1 kilogram of pure non-electrolyte sucrose has a vapor pressure of this one, so it was not given. Have only the molar mass of the solid. So let's see, the Kb was given, the density also was given. Let's see how do we solve the equation. So you can find the mole of water, which is the solvent. We have this amount of mole. Then you have the XB, we know the mole fraction of the solid is equal to P naught minus P over P naught. Here that means we have the mole fraction of the solid, we have it. What is the mole fraction of solid? Is equal to the mole of solid dividing with the total mole. Here we have it. After having it, we equal to mole of sucrose over the mole of sucrose plus the mole of water. Here we can then find the mole of sucrose, which is the mole of solid. So this is the rearrangement. Then we do the rearrangement to find the mole of solid. After getting the mole of sucrose with the mole of sucrose, we get 1.02 mole, which is the mole of solid. Then to get the molarity, we take the mole of solid dividing with the mass of the solvent in kilogram, and they are saying that the solvent is 1 kilogram. Then we get the molarity. After getting the molarity, then we replace the value to find the delta TF, delta TB, because they're asking the boiling point elevation. That means the I times Kb times M. We have all the values, you can replace them. The change in temperature then will be equal to 0.53 degrees Celsius, which will be the change in temperature or the boiling point elevation. So you need also to calculate the osmotic pressure. So we need, for us to calculate the osmotic pressure, we have the moles of the solid, but we need the molarity. So we need to find the volume of the solution, because with molarity we use the volume of the solution. Here we know the density equal to mass over the volume. The volume is equal to mass over density. Then in this case we have the mass. Have the mass of the solid. That is equal to 1.02 times the. After getting the moles, we can multiply with the molar mass so that we get the mass. So the mass of solid, we obtain the mass of solid, which is equal to 348.84 grams. So now the density is what is the density? The mass per volume, but the volume of the solution. So now we have the mass of solid, we can get the mass of the solution. Mass of the solution is equal to this one. After getting the mass of the solution, then we can determine the volume of the solution by taking the mass of the solution dividing with the density. The density of the solution was given. The mass of the solution, we also calculate it by adding the mass of solid plus the mass of solvent. In this case, after getting the volume of the solution, we determine the molarity by taking the moles, dividing with the volume of the solution, you get this molarity. After getting the molarity, then you calculate the osmotic pressure by replacing the values, then we get the osmotic pressure, which is equal to 21.6 atmosphere. Let's go to question 27. Question 27 is saying what will be the freezing point of water solution that has a boiling point of 101.7 degrees Celsius. Then you have the chi F, freezing point constant, and we have the Kb, the boiling point constant. Now they're asking what will be the freezing point of water solution that has a boiling point of this one. If you have a boiling point of 101.7, in this case, you have the delta Tb, the change in temperature for boiling point, because the normal boiling point of water is 100. If it is 100 and 1.2, that means the difference is a 1.7 degrees Celsius. The Kf you have, the Kb we have. Then we can determine the molarity of the solution by using the formula. See, the boiling point, the boiling of water is 100. Addition of solid makes solution to be elevated. The boiling point is elevated. Then the change in boiling point, that will be 1.7 degrees Celsius, the change in temperature for boiling point. And after getting the change in temperature for boiling point, you can get the molarity here. So we get the molarity, which is equal to 3.27 more. After getting the molarity, then we can determine what they are asking, what will be the freezing point of water. In this case, the delta Tf is equal to I times the molarity times Kf. Then we replace the value I will be equal to 1. Then in this case, we have the values. We are replacing the M and we are replacing this one. We get the Tf, which is equal to 6.08 degrees Celsius. Because here we have assumed that the electrolyte here, we have the non-electrolyte solution. So the freezing point, then we take 0, because the normal freezing point of water is 0. Then we do minus the change in Tf. Then we have the freezing point that they were asking. Question 28 is saying how many grams of sodium sulfate molar mass are required to make 325 milliliter of solution having an osmotic pressure of this one. Here we have the osmotic pressure. You can convert it to atmosphere. Then they are asking how many grams. They are asking the mass. And for you to get the mass, you should be having the number of mole. And for you to have the number of mole, you should be having the molarity. Let's see whether we can find the molarity by using the formula. We have here, we can convert to osmotic pressure, we can convert to atmosphere, because it was given. Osmotic pressure is equal to IMRT. Here they are constant. We can determine this M or IM. We can determine it. The molarity is equal to osmotic pressure times ART. What is this 3? Because we have sodium sulfate, that means it is electrolyte. It will give a 2 sodium plus 1 sulfate, which the I, the Van 't Hoff constant, it will be equal to 3. Then the R, the gas constant, and the temperature. Then we have the molarity. After having the molarity, we can determine the number of moles. Because we know the molarity is equal to mole of solid per volume of solution. That means the number of mole will be equal to this one times this one. Then we get the number of mole. After getting the number of mole, we determine the mass by multiplying with the molar mass. Then you have this value, which is 0.558 grams. That was question 28. Let's move to question 29. Question 29 is saying the normal freezing point of ethanol is this one. How many grams of Kf? They are asking also the mass must be added to 35 grams of ethanol, that means the pure solvent, to change its freezing point to negative 120.25. So that means the freezing point is coming from here to here. That means we have the delta Tf. The delta Tf will be equal to the difference. Then you get, after getting the difference, then you can calculate the molarity. After getting the molarity, then we can calculate the number of mole. And after getting the number of mole, you can get the mass, because they're asking how many grams. Let's see quickly. We see the change. We are going to see the change. The delta Tf will be a change in 2.95 degrees Celsius. There will be a change in the temperature. Then after getting the temperature, then you can replace the change in temperature value. Of course, we have here the normal freezing point of ethanol was given, right? We have also, they are asking how many grams of the Kf. Here we have it, Kf, the I, because it will dissociate to give the plus 1 potassium and 1 fluorine. That means the I will be equal to 2. The Kf was given, yes, it was given 1.99. Then we determine the molarity. After getting the molarity, we know the molarity is equal to mole of the solid per kilogram of solvent. Do we have the mass of solvent? Yes, we have it. So after having the mass of the solvent, then we can determine the mole of the solid, which is equal to molarity times the kilogram of ethanol. So we obtain here the moles. After getting the moles, then we retrieve the molar mass to get the mass. So we get 1.51 gram as the mass. So let's move to the last question. The last question is the question 30. That is the question that we close. There's a question and the answer on the colligative properties of the solution. Question 30 is saying, what is the freezing point of solution when 66.5 gram of water, the Kf was given, is mixed with 14.75 gram of electrolyte sodium nitrate. Here we have electrolyte. Of course, electrolyte is having two ions, sodium 1 and the nitrate. So here again, they are asking the freezing point of solution. That means we should calculate the delta TF. Then after getting the delta TF, we calculate the freezing point of the solution. See what is the formula that we have? The same formula that we have been using. Delta TF is equal to I times the chi F times M. But I, we know it is 2. Then this one we have the chi F. And we don't have the molarity. What is the molarity? That's the mole of solid per kilogram of solution. The mole of solid we have, we can get it from here. And also the gram of water we have, we can convert to kilograms so that we can get the molarity. So the molarity will be equal to mole of sodium nitrate dividing with kilogram of water. Then mole of sodium nitrate, we can get it here from the mole mass dividing with the molar mass. Again, after getting the molarity, then you can take the moles. Then remember, we need to divide the kilogram of solvent, the mass of solvent in kilogram, then you get this molarity. After getting the molarity, then you can replace the value. Delta TF is equal to 2 times Kf times the molarity. Then you get the change in temperature for a freezing point, which is equal to 90.71 degrees Celsius. After getting the change in temperature, then we know the normal freezing point of water is 0. Then the freezing point will be equal to 0 minus this change in temperature. Then we get negative 9.71 degrees Celsius.